from the configuration files that will be passed later. And if they are found, if they are set, then they will be available as attributes on the global options object. So once you register your options that are specific to DHCP agent, then you actually try to parse the configuration files. To parse, configuration files are the names of the configuration files that should be parsed are part of your RD array. So it means that they are passed as part of CLI for the service that you try to execute. So let's see what's going on inside this common config.init function, which is some Neutron-specific code. So basically what you have here is you use this global config object as a callable, and remember that before that you registered your specific options on that object, so it already knows how to parse the files. And you pass some arguments here. So first, you basically pass whatever was in your RD array, and then you also specify the project name, and that's it. After the call, this global object will have the attributes set as per configuration files parsed, and you can just access them from any place in the code. So then you see that the object is passed somewhere, and then its attributes will be accessed, and that's it. So what's inside RB? Basically, it's a set of options, either config file or config dir, and maybe some others, but this the options that the library is interested in. So obviously, the config file reads just one file, and config dir will read any files that are located in this directory. You can mix them. You can use several of them if you want to read configuration options from different files. And one important thing is that the order of those options influences the priority of the values that are passed in the files. What it means is that if some option has multiple different values set in different files, then the last bit's first. So, and so that's how you pass those different options, right? You can, as you see, you can mix them. You can use multiple of those, and for example, you see that configuration from this directory will always override whatever is configured here, right? Because the order is important. Yeah. So generally, you pass those options to your service, and everything is fine. But sometimes you do not. And in the library, we have some auto-discovery mechanism. When the library tries, even if you don't pass any specific files to parse, it tries to locate them. Yeah. So as you can see, that's basically what it means. If those options were not passed, then we try to find some configuration files. That's the code from the library. And inside this function, we get a list of configuration directories where we will try to find some configuration files. And if we go inside this function, then we see how the list is constructed. Basically, if you don't pass any options, then it will try to find some file inside your home directory with the name is .project, like .neutron. If not, then in your home directory. If not, then in etc neutron. If not, then in etc. Right? that's what we have in upstream. Also, I guess some of you know what is rel OSP, but just in case, rel OSP is an RDO-based commercial version supported of OpenStack supported by Red Hat, and it obviously has some local modifications. So here we see that this is like one of the patches inside the library for rel OSP that modifies the function and adds some more locations where the configuration files will be located. Something under USR share, right? So it depends. So there is also, as you can see on the previous slide, we try to read from user share, then Neutron, and then neutron-dist.conf. But what's this file is? So this file is an RDO-specific way to override default values for services, so that they are different in RDO than in upstream. And this file is located under user share and then the service name, and it's always loaded by all the services. Right. So it's cool that we have some way to override default values from upstream. The problem with this is that it's RDO specific, and also it makes us diverge from upstream defaults, meaning that there are some complaints on upstream on RDO list about the RDO project doing these kinds of things, because documentation team from upstream tries to prepare installation guides, and they say that it's harder for them to do it for RDO properly because they need to do additional tinkering to undo whatever we change in our default values.
As you mentioned, the order is important. This is loaded before /etc. So
right.
If you specify it in etc, it will be
right.
Over.
This file is one of the first to be loaded. So if you set something under etc, then of course it overrides, but you need to do it. So they need to document it if they want to change behavior, like revert to the upstream default. Right. That's an example of what we have in Neutron in this list file. Some of this actually maybe could be removed or should be removed. Some of this is useful. For example, we always need to set log path, otherwise your services will not start. But it does not have any default value in upstream. So your deployment tool would need to do that. We do that for our users. So any installation from the package works. We also assume that most of installations use ML2, using our AMQP to notify agents about updates for sources. So we enable this notification driver specifically. Also, we allow some overlapping IPs inside tenant networks. Kind of like tinkering like that. Also, we enable root daemon, which is a cool new way to run, escalate your privileges in agents. So, all kinds of things. And by the way, speaking of defaults, when you think about default values for your installation, you should think in this hierarchy. First, you have some upstream defaults, then you may have some defaults specific to your distribution, specific to your packages, like in RDO. And then you also have your deployment tool that also chooses some default values for you. And it again overrides the things. Also, config library is not just a library to parse files. It has quite a rich type library. It helps you to manage deprecations for your configuration options. It also has things like a config file generator that allows you to define in the code which options you want to then get into your sample configuration files, so that you do not duplicate things. So speaking of types, we have some simple types like Boolean type or string type. We have some more elaborate like multi-string option, which we'll look at a bit later. We have some very useful and very specific like port option, which would be the valid port number, or IP option, which should be a valid IP address. You can also specify a specific version of IP protocol that you want. We use them quite a lot in Neutron, and I'm happy about it. And also the library is quite extensible. You have access to the base classes, so you can override them and introduce your own types, even just for your project. So cool. Well, speaking of multi-string option, that's buster child of the project. Everyone would like to deprecate it or remove it, but they cannot because it's already used in some of the projects, like Neutron. In Neutron, we use that option to specify service providers for every service plugin that we enable. And the idea of the option is that you can actually have duplicate values. Like here, you have two service provider entries, and like it will still be parsed properly, and they will be joined in a list of values. And you can locate those values in different files, and they will still be joined instead of
confusing for users.
Yeah, but that's what we have, and we cannot, override that in one go. There should be a plan to somehow move into some other type. Yeah. So speaking of deprecation management, when you define an option and you want to deprecate that later, you can add some additional keyword arguments that would say what's like you just change the name here and then leave the old one here, and maybe say like which group it was located before, and now it will be moved into some other group. And once you've done that, and your configuration files are parsed, and the deprecated version of the option is found, then you will get some warning log message like that, right? Yeah, speaking of configuration file generator, traditionally we kept our sample configuration files inside the Git tree, and that has some issues. The main issue is that you duplicate efforts. You need to update your code to add a new option, then you go to sample configuration files, you add it there. You copy-paste the code, now you get some review comments to fix some typos, and you need to go and fix the typos in two places. Sometimes you forget to add it to sample files, all kinds of things. So you want to have a single source of truth, just the code that should define the options. So now there is a cool new thing, maybe not that new, maybe it's already served for several cycles there, but projects switched it one by one. The idea is that the library provides us with some generator tool that consumes some specific configuration files that tells the tool how to generate the sample files. So now we are able to remove the sample configuration files from the Git and just allow the code to run. That's how it's done in practice. So again, it's Neutron, the HTTP agent. We have such a file for every configuration file that we want to generate. In this case, it's the HTTP agent, sample. It has some additional properties, but the main thing here is that it gives us the list of namespaces that we want to include in this file. Namespaces are actually the definitions of options. And let's look how they are defined. So that's what you have in setup CFG. For those who do not know, that's basically we use Stevedore tool library to to define those entry points, like aliases, that then can be referred from some other code and be imported using this individual. So instead of specifying the actual import path, you could use this, and that's what we rely on here. So if you go back and see that, for example, we have Neutron DHCP agent namespace enabled, and you go to setup CFG, you see is defined here, right? So that's list DHCP agent options. That's some function. And that function will actually return a list of option section definitions. So that's the name of the section, and that's some iterator chain with the list of the options. Right? So in the end, you will get those options into your DHCP agent configuration sample file, plus maybe others that are included in other namespaces for this file. Okay, what's going on in the library? People are looking at using support for some other configuration backends, not just .ini files, some external entities. So people are working on that. There's also work, and maybe it's even already completed, to be able to automatically document your configuration options for your services somewhere next to, for example, API documentation on OpenStack.org. That would probably utilize something like generator, maybe the same framework. People also look at being able to dynamically reload at least some configuration options and make application honor that. You would be able to mark some options reloadable and then provide some callback that would be called once your service, for example, gets signal to reload the configuration. So we already have some kinds of support just for a plugin level now, but the idea is to have it for any kind of option that you may want. Yeah, now let's talk about a bit about myths that I hear sometimes from people. So one is that the configuration files that are included with the package or by upstream, if the project has not yet switched to samples, to generated samples, so that those files are somehow special, that your service must read those files, and only if you do modifications to these specific files, then they will apply to your service. It's not the case, at least from the library perspective. It only depends on which configuration files you passed through the CLI. They can be named anything you want. You can create those files, just anything. Yeah, and another thing is that configuration files should have specific names, right? Because you want the DHCP agent must read only files that have these kinds of name, DHCP agent or any. Not exactly right, even at least from library perspective. But you still want some consistency. So you want your service definitions to load some files that user would expect to be loaded. But again, library does not care. Another thing is that no one needs multiple configuration files, right? One is more than enough. I think some services actually do that. Like I guess one, I was told that. It sometimes works, but there are use cases to load multiple configuration files. And multiple, I mean really multiple. Yeah, it looks very complex, but we have excuses for every entry. That's what we do in Neutron. So let's go one by one. So first thing is the neutronrdis.conf. Basically, it's always there for every service. So we already talked about that. That's RDO defaults. Then we have this directory, which also contains distro-specific configurations. But why didn't not put in here? Well, the problem is that Neutron is very pluggable. So we have advanced service plugins that may be installed or may not. And they also ship some configuration files. And we don't know whether they are installed, so we don't know whether those configuration files are installed. But we still want to load them if they are installed, right? So we cannot just hard code those configuration file names in here. Instead, we just create a separate directory for Neutron server, and then put there anything that should be applied to the server if some plugin is installed, right? So if OBAS load balancer service is installed, put some file here with overriding some default group name to reflect what we have in Red Hat, and then it applies to the Neutron server. Okay, so next thing is simple. It's just service configuration file. I don't think anyone has any problem with that. Next thing is plugin.ini. It's our old, I would say, old way to support multiple plugins in Neutron. The problem again is that every plugin ships its own configuration file. You don't know which of them will be enabled for deployment, so you don't know which to load in advance. So we allow deployment tools to create this symlink pointing to the actual plugin which is enabled for the deployment, and then we load it through this symlink.
Why ini and unlike other which are legacy or?
It's legacy.
Learning the fact like that. Why do you care? Library does not.
Because it's ugly. It hurts my eyes when I see conf, and
library does not care. Right?
It hurts internal.
I was not there when this decision was made. Yeah, and also we have something, and we will talk about this something later. Yeah, so some problems that people do in upstream when coding. Sometimes it seems that it's easier to hack around some quick solution and re-implement some part of configuration parsing, at least for something. We actually did it in Neutron for service providers when we were splitting advanced services into different repos. And there were some concerns that we had the default option defined somewhere. Well, I won't give you much details, but anyway, in the end, we ended up with a separate ini parser for some specific files, for some specific option, which actually used the Python standard ini parser and whatnot, and then merging values. We still have it in the tree, and it's ugly. It's ugly not only because we re-implement oslo.config, but also because there's magic. Because those files, we don't explicitly pass them as CLI options, but just they are magically loaded because they have special names, Neutron, something, and then they're loaded. Don't do it. And why? Well, because it's complex for everyone. It's complex for operators because there's some file that is loaded, but it's not passed as a configuration option. Why is it loaded? All kinds of questions. And basically, there was no reason to do that. It was just a quick solution. Okay, so back to Autodiscovery that we talked about. When you don't pass any config file or configure options, then magic happens. Library tries to find some configuration file somewhere. And you don't want this to happen when you run in some environment that you want to really control, specifically for unit tests. Because the reason why you don't want that is that, let's say, some configuration files that match the library assumptions about configuration files that could be loaded. are installed on the system but are not available because they have some permissions restricted. Like etc neutron.conf is installed, but it's readable only by root. And then you try to run some tests as a simple user. The library tries to read the file because it's there, but it's not available, so it will fail with permission denied, and that will occur in your test environment, and tests will fail. So you don't want this to happen. So you need to basically disable this auto-discovery mechanism. And how you do it depends. In Neutron we had multiple attempts to do that. So one of the things is that in our base test class we have this static method, config parse, which is called from other place for every test case. And what we basically do here is we put some weird, unneeded file in the CLI arguments, just so that we disable this auto-discover mechanism. Because once at least one of the config file arguments are there, then it's disabled. So we just create an empty file and just pass it into the library here. And then we disable this behavior. The problem with that was that some test cases overrode some superclasses methods, and they were not actually triggering that. By the way, here you see that we pass some result of this method, of this function, and here's the implementation of this function. It basically, this file, the file is under Neutron tests. So this is the root dir, and you here you will get Neutron test etc, and we just return the neutron.conf file from there. And this file does not contain anything interesting. It's just so that we are able to disable the mechanism.
Shouldn't there just be a flag in slow config for it? Why is no? It's another of these why question. Why is there another flag to disable it in Oslo config?
Yeah. So that was the first attempt. Also, another problem is that sometimes it's not like base test case that you can execute something, but that's our PEP8 target for talks. And there we want to check our migrations. And this is another tool that again, uses a slow config library. And since we do not really need any of the options from any files because defaults work for us, we don't really need to pass anything. So, and we did not pass before. But then, again, we discovered that if the file is installed and permissions are denied, then this will fail. So we added this just in case so the mechanism is disabled. So we do a lot of stuff just to undo what library thinks is best for us. Yeah. Also, we have this. Probably we need either this thing or this thing. Probably not two, but it works. So no one wants to touch anything. So we monkey patch some function from inside the library that we know returns the list of those files that probably be loaded if we don't pass those options. And we just make sure that it returns nothing. And actually, Oslo library authors realized that it's not okay. So they, since recently, they shipped some fixture for tests, and that actually has a way to influence the mechanism. Basically, if you don't want to pass it to trigger the mechanism, you just call this method with empty list, and it will always will be returned to your code. But for what I saw on code search, .openstack.org, no projects use it. So we should adopt them.
Too little, too late.
Sir?
Too little, too late.
Yeah, everyone already fixed that. Yeah, and that's basically it. And I will move to the last part. which is the this. So what are those additional configuration directories? We added them quite recently, I think in February. And first, the problem we are trying to solve. So as I said before, we had, and we still do, we still have this plugin.ini mechanism where deployment tool can change the plugin configuration file to be loaded by the server. It worked mostly fine. Then we had this advanced services recalls code split from the core Neutron, and every service started to ship their own configuration file, and we did not know what to load. We would need to do that depending on what's installed. Also, another thing is that, for example, for ML2 plugin, we have some base configuration file that ships that contains some common options. But then we again have all those tens of drivers for ML2 that each ship its own configuration options. And again, you don't know which drivers are enabled, so, and you cannot even, like, if you would even want to just pass all of them, you don't have the list because some of those drivers are maintained as separate repos. We don't even know about their existence, and we don't know about their configuration files. So we need some way to influence which files are loaded by the server without making any change every time for our service files, right? Yeah, and sometimes, like in Red Hat, we have some partners who want to certify their stuff with our OpenStack distribution, and they want to load their configuration files. And they reach out, like, we have the configuration file, but the problem is that it's not loaded by your service, so please do it. And we can't, like, do those kinds of modifications every time. So that's the problem. And the solution that we came up is having some configuration directories that are created under etc Neutron that are loaded by the services as directories, not as files. And deployment tools maintain the contents of those directories. Right? We have a directory per service. So Neutron server has its own, DHCP agent has its own, and so on. And we also have some common directory that is loaded by all services. Like if you want to enable debug, then you just put in this common directory and restart your services. And we also we ship those directories, we load them by all the services, and we also make it public that the ordering is guaranteed. It's like part of our RDO guarantee. Yeah, so that's how you would use it. You just create some file under this directory, for example, for Neutron server. You just want to enable debug for some time, right? So instead of going into etc neutron.conf and setting the debug to true there, you just create a new file, you put whatever you want to be loaded there, then you restart your service. Here, this file is loaded as part of this configuration directory. Then you do your stuff, collect logs, and once you're done, you just remove the file or comment out whatever options you've set, and again restart the services, and it's magically applied.
So when you said the order is documented and maintained, is that the order of directories or the order within directories?
Both. So first thing is the order of configuration arguments is maintained and guaranteed by the library, and also the order of files inside the directory is also guaranteed. And the guarantee is that they are loaded by the sorting order of file names. So that's, I think some distributions, some projects have this kind of convention, like you put some, like in Gentoo, you put some file called 02, and it's loaded before 99 something. Yeah, so the benefits is for Neutron, basically, that's understandable. We don't have the lists to load, so we try to come up with some generic way. At least some of other projects may see a value in that. And maybe after that's adopted, it could be actually used somewhere apart from the packages itself, but maybe in some deployment tools. So I kindly ask everyone to consider that for your project, and maybe.
Yeah. So, and I reply with a question: how big are the requirements of the Oslo config? Like, if I have a lightweight project, I would really hate it to pull too much horrible things like
That's
PPM.
for
No,
other
I'm not
OpenStack
talking about
projects.
your end of
Yeah,
projects,
yeah,
but
yeah,
more
yeah.
about OpenStack services that already have.
But not all projects are using this. I thought it's like a different
All OpenStack projects are using
Yeah.
Yeah. So I remember that I was approached by some Ansible folks about this. They saw that, they seemed to like that, but I haven't actually, like, before the presentation, I've checked on the code search. I haven't found any trace of that actually used. So they probably decided that it's like too platform specific, which is reasonable, right? So I say that probably it won't fly as a general solution for every distribution, but if you don't care, for example, if you want to do something just for RDO, or maybe if you want to do something just for OSP, like you want to work with your partners to certify some specific driver, then you definitely can use that. And we use that for some Neutron drivers already. And so that's basically, so now it's the time for the questions.
In some slide, you mentioned storing config options in a database. Is there a blueprint or a spec about it?
I think there's a general spec for working on the framework for that, and then it should be fundable.
Because in Keystone, we have to manage this by ourselves, storing config options for the links.
Full disclosure, I'm not actually part of the Oslo config team, so I'm more of a user. I did some RDO work and just fixed a couple of things in Neutron to cope with the library. So it's, I don't know.
You mentioned that there is a function that generates the list of options you're interested in for the kind of default values, right? Yeah, precisely. Thank you. And how you use this function and later on in the code to get the same, when you register your options to the config parser. So you don't maintain in two spots, right? I mean, the list of the options.
Yeah, so basically the idea is that this function is then used in the code itself when you register the options. Basically, when you register, you just get the result and pass it into the registration function, right? And at the same time, you use the same code, passing it through stevedore into a generator. So once you do the change here, or in one of those lists, it will get both in the code and in the generator.
So basically, to register, you just need really the list of these things, nothing additional is needed.
Well, the generator will get basically a list of option definitions. It will have access to the help string that it will put in the generated sample file, and its type, and deprecation status, everything.
There's usually a bunch of configuration options that are basically the same for every single project. Let's say browser queue, connection, cache, keystone, URL. Has there ever been any attempt to just bundle them together into a single configuration file that is originally loaded by all the services and then maybe overloaded after that? Because that would simplify it. You don't have to. Everywhere. Exactly.
I'm not sure whether it would be a completely general solution, because I may think of some use cases where you want some services to switch to some keystone version or something. And others not to do that.
With Oslo config, you could override it in the service-specific configuration file. You don't have to do this already. That's right. But you can have some generic-based options for everyone.
In theory, yes. Just, again, have a very common directory that is loaded by all OpenStack services. Okay. Okay.
Thank you very much.
Všechny ty informace třeba.
I should have found a different spot at the end of the room.
That's probably why when you go to not there. You want to clear how to list of
Yes, a few minutes or so since I saw.
Yeah. Oh yeah, we need to stop that.